Greetings from the Philippines. I'm tasked to present for the 2023 Forum on Renewable Energy Promotion in Developing Countries. My presentation is about quantifying the levels and components of cookstoves emissions using a dilution tunnel system done in the Philippines. As an introduction, the Philippines has a national university, and the name is University of the Philippines. It is a premier institution of higher learning and is established in 1908 with 24 centers of excellence, institutes, and 6 centers of development. We have 8 constituent universities and 1 autonomous college. The UP Diliman has 17 campuses all over the Philippine archipelago and is ranked 17 in Southeast Asia in terms of QS ranking as of June 2023. Yep. Okay. So I am Mylene Cayetano. I'm an environmental scientist. My expertise is on environmental quality, short-lived climate pollutants, aerosol and atmospheric chemistry, ground-based measurements, science to policy, and community interventions. I'm also the head of the Environmental Pollution Studies Laboratory, which has a vision and mission and goals stated here. So the vision of the EPSL is solutions to environmental pollution are within reach. And our mission is to provide evidence-based information leading to solutions on the pressing and emerging environmental pollution issues on water, atmosphere, food, and energy in the Philippines through teaching, research, and extension service. The goal is to address the environmental health challenges in water quality and air quality management using evidence-based approach. So we include here in under the category of energy and food, our studies on cookstoves. Hence, the outline of my presentation is divided into 3. First, I will introduce the importance in doing cookstoves emissions measurements, and I will present the UP Diliman dilution tunnel system and testing protocols. Lastly, I will let you know the levels and components of cookstoves emissions that we have studied in the laboratory. But again, the major question is why cookstoves emissions measurement? Well, simply because it is cookstoves, traditional cookstoves is still a ubiquitous way of cooking in the Philippines. So traditional cookstoves in the Philippines, such as cement stoves and open pit rock stoves, which both uses charcoal and fuel wood, are still being used ubiquitously. It is utilized for low-cost cooking, for small-scale income generation, for meat grilling, or simply for cooking daily food, traditional or modern. Traditional cookstoves are commonly found in underprivileged sector, the poor sector, who cannot afford cleaner alternatives. Small-scale cookhouses proliferate in cities and are not regulated. So based on estimates, based on the household energy consumption survey in 2014, done in 2011, there are around 54% of the population who still rely on fuel wood, while 36% rely on charcoal, both of which are solid fuels for cooking and heating. And this number of users translate to around 41,000 deaths and more than 1.4 million disability average life years or DALYs due to use of traditional fuels, and this is as of 2017. So with a population of 110 million and rising, people are exposed to unhealthy levels of pollution from using traditional cook stoves. And part of the emissions that we studied are the carbon monoxide, carbon dioxide, nitrous oxide, and sulfur dioxide, and specifically the components of particulate matter. But for this report, I will let you know about the levels and components of emissions from cook stoves in particulate matter. So, again, there are polluting levels that remain to be a barrier in providing clean and accessible energy for the underprivileged Filipinos. And these emissions from cook stoves has implications on other sectors such as health and environment. The usage of traditional fuels provides required energy for households. However, inefficient cook stoves and solid fuel burning results in a range of health and climate damaging emissions. The particulate matter emissions, specifically from cook stoves and by using solid fuels, contains black carbon, or BC in short. BC is a short-term climate pollutant emitted by solid fuel cook stoves. Such fuel products increase the greenhouse gas emissions and short-term climate pollutants in the atmosphere, creating changes in the global climate system. Recent studies have shown that black carbon may be responsible for close to 1/5 of the Earth's warming, and that residential solid fuel burning produces up to 25% of the global BC emissions. In 2014, the World Health Organization recommends the following items so that we can help in alleviating the conditions of our underprivileged sectors, specifically the household who still rely on household fuel combustion for cooking and heating. So the recommendations contain specifics about what should be the emission rate targets so that we can attain safe levels, how to support technologies for cleaner cooking solutions, and how to synergize between health and climate impacts while using traditional cook stoves. So the purpose of the recommendation is to answer the question, what device and fuel emission rates are required to meet the WHO annual average air quality guidelines and intermediate target 1 for PM2.5 and the 24-hour average air quality guideline for carbon monoxide. So the emission rate targets that the WHO recommended is that it is recommended that emission rates from household fuel combustion should not exceed the target stated in the table here. So which should be for vented and unvented, the emission rate target should be 1.75. For unvented kitchens, this is for PM2.5, and for vented, it should be 7.15. So if these emission rate targets are complied, the WHO guideline values can be complied as well. And this emission targets should not be exceeded for PM2.5. Then the second recommendation is to answer the question, what device and fuel emission rates are required to meet the guideline values that can provide a suitable basis for selecting appropriate devices and fuels. Therefore, a second recommendation by WHO is this: the governments and their implementing partners should develop strategies to accelerate efforts to meet the air quality guidelines. And then, where intermediate steps are necessary, transition fuels and technologies that offer substantial health benefits should be prioritized and supported. And then there's also a third recommendation, which state that unprocessed coal, including charcoal, should not be used as a household fuel. Hence, to follow on these recommendations, my institute conducted the study on quantifying the levels and components of cookstoves using a dilution tunnel system. So I present to you the UP Diliman dilution tunnel system and testing protocols. And our technology supports the 3 recommendations by the World Health Organization. The technology is composed of an enclosed system with a variable speed blower to mix ambient air with cookstoves emissions before sampling, a testing chamber where the stoves are tested and the fuels are burned, a sampling chamber for the collection of smoke samples, and an exhaust system to minimize the emissions in the atmosphere. It has a cross-section area and a hydraulic diameter of 0.5 meter. So these are the chambers in its actual design. So at the beginning of the sampling day, the UP Diliman dilution tunnel was cleaned with a diluted detergent, rinsed, and then air dried by turning the electric fan or the variable speed blower for at least 15 minutes. Temperature and wind velocity were measured at 4 different points: at the blower section, at the test chamber, at the measurement chamber, and at the exhaust outlet using portable handheld anemometer. So the average wind velocity in each section are from 2 to 4 meters per second. And average wind velocities in each section remain the same during the background and testing, except in the sampling chamber itself, where the temperature change may have been greatest. The average temperature in the test chamber is about 36 degrees centigrade, and the average temperatures in the other points are 32 degrees centigrade in the blower part and 34 degrees centigrade in the sampling chamber part. In the exhaust, it's 33 degrees centigrade. A unitless parameter called RE, or the Reynolds number, is used to indicate the flow regime of the UP Diliman dilution tunnel system. So where in the Reynolds number, ρ is the density of the dry air at 1 atmosphere and 20 degrees centigrade. U is the velocity, and another U. L is the hydraulic diameter, and V is the viscosity of the dry air. And in our study, this is the tabulated measurement points and the remarks on the Reynolds number, indicating that the measured Reynolds number indicates that the flow is turbulent, and the turbulent flow mimics the actual condition in cooking inside the kitchen. Since we know that the anthropogenic aerosol particles are emitted from the ground and will eventually be mixed in the atmospheric aerosols to take part in the tropospheric chemistry, we set up the devices for particulate matter measurements using research-grade equipments to sample PM 2.5 from the ground, from the emissions of the cook stoves. And the PM 2.5 is after sampling, it is subjected to chemical analysis, optical characterization, and hygroscopic characterization using the equipments indicated in the figure. Also, all throughout the conduct of the experiment, we follow the water boiling test laboratory protocol, which consists of 3 phases that immediately follow each other. So we have the cold start, the high power start, the cold start, the high power phase, and the cold start, the hot start, and the actual boiling. So the cold start high power phase towards the laboratory test begins at room temperature and uses a pre-weighed fuel prepared beforehand and uses 1.5 liters of water in room temperature for boiling. And these are the results. So we found levels of ions, water-soluble ions, in different types of cook stoves that we tested. So we tested the cement cook stoves, we tested a kerosene cook stoves, this brown one. We also tested fuel wood and we tested sawdust. And these are the levels that we found out. So we found levels of water-soluble ions, soluble trace elements, most of which are trace minerals. We also found levels of lead. And then we also found levels of water-soluble particulate carbon, in which these are higher levels, around 25.1 to 35 micrograms per cubic meter in level, which is high in our perception. The same protocol was used to determine the levels of water-soluble sugars, levoglucosan, manosan, and galactosan, and we found also levels elevated, reaching as high as 80 micrograms per normal cubic meter. The same protocol was used for our studies to differentiate, to determine the average emission concentrations by each pollutant, such as carbon monoxide, sulfur dioxide, and nitrous oxide, and to determine the thermal efficiencies of the different cook stoves in cooking fuel. In summary, our study on cook stoves and solid fuel use determines and confirms that it has impacts on health and the environment because using traditional cook stoves and fuels emit levels of air pollutants. The WHO recommends interim solution to manage the indoor air quality due to household cooking. Performance testing is critical to justify the claims about the real impacts on fuel consumption, greenhouse gas emissions, on air pollution resulting from the use of traditional cook stoves. So our study supports the WHO recommendation, and testing protocols can be used in future initiatives that will recommend improved cook stoves. I would like to thank our partners in this study listed here, and thank you very much for listening.